Hello, everyone. Welcome to, Welcome to USD with me. All right, so today we're going to be looking at Blendshape's. So this is a continuation of the UsdSkel topic. For the last few weeks, we've been building a basic skeletal rig for a rectangular prism, an arm representing an arm, binding certain vertices to different joints, and then seeing how that deforms when you animate the rig. So that all worked out really well. The next concept that I wanted to cover is blend shapes. So these are basically alternate shapes for your mesh that you can define, and you can interpolate between them. So this is really common in visual effects and animation, where you may have different facial expressions for a character sculpted, and then you include those as blend shapes for your character rig, and then you can animate between those blend shapes to create the facial animation. Another concept, another place where you'll hear about this is in audio to face. We use the blend shapes for the producing the animation of our characters. And same thing with, say, if you're in the AR world, the kind of stuff that they're doing with facial, capturing your expressions with your phone, and then creating like the Snapchat avatar animations. That is all also used as blend shapes. So, the idea for today is to we're going to use a very simple shape, probably just a triangle, and then we'll store a couple of different variations of that triangle. It'll probably be like a equilateral triangle, and we'll morph it into an isosceles triangle, etc. So that we can easily see how the data is being encoded and how that works. Extraordinary brings up a good point. And you can use blend shapes to morph anything and do some simple limited animations with that. So you could take a bush and you can sway it a little bit to the side and kind of simulate some sort of physics there without that computation. Very popular technique. And let's get into it. So we built this basic Skell script for that arm. I think we're going to start fresh. We won't need everything. We'll do a new file. We'll call this one but we are going to leverage a lot of this stuff. So we've got our imports. We need to create a stage. We need all this stuff. So we'll go ahead and use it. And feel free to shoot out any questions while we go along. 10 frames should be enough. We're going to call this try for triangle. This isn't quite taking. There we go. We got our root. What else do we need? We did set the default prim. Good. All right, we got to define this mesh. So unfortunately, got to do this bit again. Try. How about morphing try? All right, and then that's going to be our Skell root. Then we need a mesh, and we're going to call it morphing try mesh. And as always, we need all these bits, but we're just doing a triangle. I'm not going to be ambitious here. So that should be easier, hopefully. I just have to do 3 points, one face, and we're going to define, we're going to have it face down the Z. So we need to go along X and Y. So first one, we're going to go negative X. Then we're going to, we should go in winding order. If I remember correctly, let me take a look here. I think meshes are, whoops, what is that? You know what I want. There we go, USD on mesh. I think meshes are counterclockwise winding order. I'm gonna get this right this time. It's gonna be in this other one, USD this one. Why did it? Come on. USD Ah, there we go. Winding there. Right-handed winding rule determines hold on. Okay, that's orientation. Okay, so it is right-handed by default. And so that means right-handed. I'm still gonna get it wrong. If anybody has this, please let me know. Use the right hand grip rule, thumb stick out. So I think it's counterclockwise. I had a better one for this, a better resource for this. It's probably this one. Ah, there we go. So right hand rule is the way that the thumb sticks out. So that's counterclockwise. I don't know. I find it easier to remember it that way. Maybe that's the wrong way to think of it, but let's try it. So let's start to the right, positive 0.5. Then we're going to go up, and we'll figure out if I did this right. We're going to go up 1. So each side will, I think that's what we want. And then negative 0.5. Okay. So we go to the right, then up, then left. And so if I did that correctly, our face indices should be in the order of the way that I define my vertices. And then this is 1 face with 3 points. Anything else that I need here before we run this and see if how wrong I got it? Okay. Here we go. I need to open up USD view. And then I had my terminal set up for this before. I don't now. What is the best way to do this? Let's try this. I have this poetry shell over here that should have USD in it. Did that work? OmniCode with me. Scripts, create Blendshape. This is going to put it totally in the wrong spot. Looks like it worked, but I need to change my directory. Let me just find it, make sure I did. Make sure this is working. Code samples. Looks like it worked. Yeah, okay, so let me just move myself around here. Okay, so now when I do Python scripts, that should put it at the root of my directory, of my project, and there it is. Beautiful. So now we should be able to open this up in USD view. Not that one. That was me fooling around earlier. This one. And it looks like I got it right. So I wanted it down to face down positive Z, and that's what it did. It went right, then up, then left. Because I know that worked because otherwise on the other side it's not double-sided right now. Great. My math is not so good. What do I want the y value to be if I want an equilateral triangle? If somebody wants to answer that one. It's like 100 times harder to do math on live stream, even something simple like that. So if anybody wants to throw me that number, please do. In the meantime, we'll move on and keep going with our stuff here. Okay, so let's define a blend shape. If we look at the documentation, you can have blend shape in between. So we'll talk about that in a little bit. But I thought there was more to this. Maybe I'm looking at the wrong doc. I don't think this one shows blend shapes. Also, I realized that this API introduction actually has a pretty good example for a full skeleton, right animated skull. So there's that in case you want to look at that one too. So for the most part, we're going to be defining a blend shape. This is a little bit like a USD geom subset. So you can extraordinary says height is equal to square root 3 times a over 2. What's a? Is that my side length? Anyways, so Blendshape is kind of like a USD geom subset. It's a prim that lives underneath, inside of a mesh. So I can define face sets with USD geom subsets. So I can say, if I had a cube, I could say the front face, I'm going to make this a face set, and then I could use that to bind a different material to that front face, for example. Blend shapes are similarly defined. They are prims inside of a mesh, and I believe you give it just the list of point positions of where they should be. You're basically redefining the points, if I remember correctly. I read over this recently, and I thought this was easier. I thought this was more explicitly written out. But we'll just go ahead and look at the API. So we're going to create that blend shape, and we'll call it, let's fix the equilateral triangle. So extraordinary saying that is how you do the height. So what is that? I think I need math. Square root. Three times 1 over 2. 0.5. I guess just to be explicit here. All right. Is the square root a part of the standard library? There's math square root. There is also, no, okay. So I got to do the import. Import math. And here we go. Nice, thank you. Okay, now we're cooking. So let's take a quick look here again at the documentation. So we're going to create, we need to define this blend shape, basically. So let's come over here, and we're going to say, I saw. Next up is, how do you spell isosceles? We'll just call it ISO. UsdSkel blend shape, define stage, and we're going to put it below our I think I can get path off of the mesh. Append child ISO. Okay. Let's make sure that worked. This isn't going to do anything yet, but let's just make sure. There's the blend shape. Beautiful. All right. And so what can we do with this? This one, right? We can create an offset. It doesn't say there what that is, but that's the one we want. Yeah. So there it is. It's given by the offset property. I think this documentation could use a little bit more scannability. Just like it should just have an offset section here, so that because that's like the main thing you want to define here. Instead, it focuses on in-betweens. Let me add a note for myself. I'm also going through here and trying to improve the documentation, hopefully. So add offsets heading to improve readability, scannability. And feel free to shout out if there's something in the documentation that you see that you think could be improved. As I'm doing this, I'm willing to add in any improvements that we come up with together. So we're gonna do iso.create offset adder, and we're just going to set that with some new points. And you don't have to redefine the whole thing, only the points that are moving. And the reason for that is because there's also ISO create point indices adder. So similar, so we're going to say these are the positions that we want to redefine. And these are the point indices for those that correspond to for which we're applying these offsets. So we're going to set that one too. And all we're doing here is just the top one. So we're going to set that to index 1, right? The middle one. And then for the offset, I don't remember if this is relative or world. So let's take a quick look here. Positional offsets are multiplied against the corresponding weight. Yeah, we already know that. And then they're added, I believe, added to the original position. So theoretically, if we want to double this, maybe 2 times. Call this EQ try height. Oh, what am I doing? Okay, so now if we say 0, we just need to define this point. So 0, or the offset of that point, times 2. Or rather, we just add it. It's going to be added, so we're just going to add the same amount to it if I got that right. I didn't need to double it. Okay. Let's go ahead and just check that. Still shouldn't do anything, I don't think, because we haven't applied those, told it how to apply the blend shape yet. But it's got that offset, it's the same amount, so it should theoretically add that amount to the same mesh point. Next up. All right, now we got to do some scale stuff. So we're going to do, we're going to bind, we got to do the, should probably, no, that's fine. UsdSkel binding API, our favorite. Apply. And we're going to get the mesh prim. And this is going to be feel like it's more natural to say mesh binding. Okay. Cool. Mesh binding. We're going to create the Blendshapes attribute. And we're going to set it. Oops. I don't know what. I just pressed a hotkey for the terminal. What is this? We need that one. We also need create Blendshape targets relationship. So if I remember correctly, these are there it is, binding Blendshapes. This is what I was looking for. Where is this? I guess it's part of the binding API schema. Okay, I was in the wrong area. Cool. So given a skinnable primitive, which is our triangle, the Blendshapes and Blendshape targets properties of the binding schema specify a mapping from animation of the bound skeleton instance to different skinnable primitives. To bind Blendshapes, we need the targets property and set the target to the Blendshape prim. Additionally, the Blendshapes array should also be defined, providing a unique token per bound Blendshape. Okay, so we're going to give. So these are the paths, and then these are going to be the just kind of the pretty name for these Blendshapes. So we have our ISO. And remind me again, what do targets want? Targets want a prim or a path? They want a path. So ISO get path. And then for this one, we'll call it ISO. Can you teach ChatGPT to do Blendshapes when you train it? I think so. I think I haven't tested it yet. I don't know why I'm not testing these things while I'm learning them, but from what I've seen, I'm fairly certain it can get this. Cool. Okay, so I guess we can stop here and take a look. Set this one's targets. Okay. Reopen stage. we look at the mesh, we have Blendshapes token is defined and the targets. So that's all good. And we should have the scale binding API applied on that mesh. Everything is good so far. So I think we can define our animation now. Come over here. Anim is equal to UsdSkel. So if you remember from last time, we have an animation prim, and we are going to define stage. And same idea, we're going to get, add it right down to the scale root. I should have done that up at the top too. Get path, append child. And this one's going to be called anim. Okay, and then the anim has Blendshapes adder and Blendshapes weight. What are those? Here's the anim. Blendshapes are right. So this is an array of the Blendshapes that we want to activate. And then this is the weights that we want to apply for those Blendshapes. In this case, if I understand correctly, we aren't doing time samples. So this would just be kind of the default shape that we're going to, once we set this animation source, this would be the default result of our creation. But if we wanted to animate it, then we would do time samples for these. So we should do both just to see that. Okay, so Blendshapes is just the token names, and then we'll do the weights. We only have one, so this should be fairly simple. Create Blendshapes adder, set ISO, and we could do better. We could define variables and reuse them instead of hard coding all these values, but nobody wants to watch me define a bunch of variables. And here we're going to set it to 1.0. This is all in here. It talks about what those weights mean. If I remember correctly, you can overdrive them. So yeah, because they're defined as offsets. So let's try that. For now, we'll do this. Okay. And then we're going to apply the animation to the scale root. So did I do that right? Did I forget? I believe I forgot the skeleton, didn't I? This is my scale root. Let's add a skeleton. I don't think we technically need it. I like to test all these things to see what we do and don't need. Let's try without it. We're not defining a skeleton. I don't think we need it because we can put that binding on the scale root, and that's typically recommended. So root binding is equal to UsdSkel binding API, apply scale root, get prim, and then root binding, create animation source relationship, add the target, anim, get path. Okay, so doesn't quite look right. And then our anim has token, weights, and we applied the anim onto there. All right, let's try adding that skeleton. And I don't think I used it for anything else here. Yeah, I should do, I need to bind that. Scale root dot create, nope. Scale root binding, sorry. Create skeleton relationship, add target, do set targets. And we're going to do ScaleGetPath. Okay. So at this point, what do we have missing? This is, I messed this up. This should be a scale, not scale root. That would probably cause issues. Rerun it. Reload all layers. All right, well, that's looking better. Let's check this against this one. Binding skeleton. Okay. Question was, where can you get your code from this example? Once it's working, it will be on, what is this called? OmniCode with me. So this repository here that you're seeing me work in, it'll be there. So it'll be in the scripts folder. So there you go. Let's take a look at that example again. See where I what liberties I took and where I might have broken it. Okay, so they've got skeleton, which has nothing defined, anim. They have the mesh that defines that stuff. It also defines a skeleton. Did I do that last time? And animation source. Let me take a look at, what did I do here? The mesh. I created joints. I did set the skeleton target. I put the skeleton relationship on the mesh. What else did I do here? And then the joint properties. So let's go ahead and do that. Instead of root binding, I'll clean this up. I gotta see what's going on here. And I copied the wrong line. This is the one I wanted. Okay. So now what does ours look like? We have that skeleton up there. That's not even parented to the root. That would also be a problem. So everything needs to be contained inside of the root. Where did I put it? I put it in, so it should actually be scale root, get path, append child, scale. Okay, so we are getting there. Now the mesh defines which skeleton is affecting it. It's got the Blendshape targets. Let's give that one a try. Animation source there. I feel like I should be allowed to put this skeleton binding on the root. Maybe the main issue was that I didn't have the skeleton under the root. Definitely broke it bad, because now this isn't even displaying. All right, let's go back. We're doing so great until we actually had to test this and make it do something. I did have it on root that time. So we're going to go back to binding on the mesh, and we're going to look at that example one more time. Mesh as the binding on the Skell. And then the anim is next to the Skell. Those are the weights. So what does mine look like now? I've got blend shape targets, blend shapes. I need to rerun this because I changed it. There we go. And I'm pointing to the skeleton. And please let me know if you see something that I don't here. The only difference is maybe, where did they put their animation source? They put animation source onto the mesh, which is weird, but let's do it. The reason I'm really insistent on putting it up here is because of the idea of being able to instance this quote unquote character multiple times and apply different animations on each instance. This is the way to do it. You need to find animation source property on that scale root or the top level prim. But we'll try it just because nothing's working. So we're going to put this on the mesh, right? That's what they did. So now ours should be exactly like theirs. The only question is, did I do the values for the target blend shape correctly, which I think I did. But I think we have bigger problems because nothing is drawing. So I have something really bad here. Just taking a look to see if I see anything else here from when I did this earlier. All the same stuff. And then on the skeleton, in this case, I put the animation on the skeleton. So at this point, yeah, so this is what I had. I had root binding, and then I need to define a new one here. Scale binding. And we're going to put this on there. Where is my USD view? Did I close it? Probably. Let's launch it one more time. And I didn't run this yet. Same bustedness. I don't know where I went wrong. I guess that's what I should debug first, is where did I go wrong to mess up the rendering? I think these are okay. It's probably going to be somewhere around there. So here we were fine, I think. Okay, that's where we were fine. I guess when we applied the binding on scale root, that's where things went wrong. No, that's okay. And what should be the next one that we should do? I'm going to follow it exactly like the one that I had. Let's define a skeleton. Reopen stage. Still, nope, that's where it broke. But if I bind, if I add nope, I didn't do it. Where did I have skeleton bound? I had it on root, but what happens if I apply it to the mesh? I need to be really focused to run before I try to reopen the stage. Otherwise, I'm not doing anything here. Okay, so definitely it broke when we added the skeleton. And I wonder if it's because there aren't any joints defined. Okay, well, let's keep going. So we got that. And let's take a quick look at this example here. Skeleton. So I really want to go back to my original game plan, which is we take the root binding and we apply the animation to that. Because that feels like that one should. I didn't run it. That one should still be good. Okay, so we have an animation source. Now the bits that we're missing. Take a look at what ours looks like. We've got the binding scheme on that. We've got the two blend shapes. We've got animation source on the scale root. I do think I need to introduce that skeleton, but whenever I do, it busts. What is wrong with just saying, oh, I wonder if it's because... Let me run this again. I was just curious if maybe I was looking at the joint. That would be annoying. I'm not sure why that breaks. That doesn't seem like it should break. There's nothing offensive about that, I don't think. And then in the basic scale, we bound the skeleton to the mesh. All right, I'll have to continue to debug this offline, and we will wrap this up next week. But that looks right to me. Well, the question is, do they have an example Blendshape hello world you could use? That's what I've been following. I mean, I guess, unfortunately, this isn't complete, right? So I can't just copy and paste this. I can't copy paste this and see a result. So that would be a definite doc improvement to be able to just have something as simple as mine, hopefully. It's not too much longer, but it will hopefully be a fully working example. We don't care about any of those bits. Was there anything else in this USD Blendshape schema? Probably not. And what happens? One more thought. What happens if I never bind the? Oops. What happens if I never bind the animation? Maybe my animation's bad. Yeah, so the goal will be, I'm hoping that I can give that this code will be a full example code plus the full example USDA to go with it. Hopefully that'll help and not get people in this situation. I'm also fairly certain that offset is not defining a new position, but just how much to add to that position. So I think that's right. Weights is right. All right, I won't fiddle with this anymore on stream. Any final questions before we go, other than why doesn't it work? All right. Let me see what we have going on here this week. We have how to create AI generated 3D models on Wednesday, and we have engineering design in Omniverse on Thursday, and developer office hour on Friday. I'll need to check with Ashley. I don't see her stuff in the calendar, but I think she's maybe off this week since she does have next week scheduled. So that's this week. I hope you all have a great week, and I'll see you on Friday.